Okay, now 16 is about L'Hopital's rule. Number 1 here is the limit as x goes to infinity. The natural logarithm, or part A, I suppose, natural logarithm of x, the square root of x. Now this goes to infinity over infinity. Let me rewrite the square root of x as x to the 1/2 because I'm going to have to take derivatives. But this is infinity over infinity. Log of x goes to infinity as x goes to infinity, and x to any positive power goes to infinity as x goes to infinity. So this is infinity over infinity. I can use L'Hopital's rule. So I go ahead and I do that. What I get is the limit as x goes to infinity of the top is 1 over x. The bottom is 1/2 x to the minus 1/2. Okay, now here, this is still, this actually becomes 0 over 0. 1 over x goes to 0, and x to the minus 1/2 goes to 0. And you can start applying L'Hopital's rule over and over again, but it turns out that you're just going to be sort of stuck in a loop. Instead, you should just notice that these are powers of x, and I can simplify it into a single power of x. X to the minus 1/2 is the same thing as 1 over x to the 1/2. So the bottom is really 1 over 2x to the 1/2. Then I can I can divide fractions by multiplying by the reciprocal of the bottom one. So now I've got x to the 1/2 upstairs and x downstairs. I can cancel x to the 1/2 upstairs, leave me with just x to the 1/2 downstairs, or really I'm subtracting 1/2 from the implicit exponent of 1 downstairs. And so I've got 2 over a positive power of x. The reciprocal of a positive power of x goes to 0 as x goes to infinity. So this is really just 0. Fantastic. Okay, let's look at part B. Part B, we have the limit as x goes to 0 of e to the x minus 1 minus x over x squared. If you just plug in 0, you get 1 minus 1 minus 0 over 0, which is 0 over 0. So we can apply L'Hopital. L'Hopital tells us that this is the limit as x goes to 0 of the derivative of the top, which is e to the x minus 0. Derivative of x is 1, so minus 1. Over the bottom, which is 2x. You plug in again, you get 1 minus 1 over 0. That's still 0 over 0, so you can do L'Hopital again. How do I know I'm making any progress? Because the bottom is a polynomial, and the degree is getting smaller each time. Eventually, the degree is going to be 0, which means that I'm left with just a constant, and then I'm going to stop running into this problem of plugging in 0 and getting 0 on the bottom. So anyways, the derivative of the top becomes e to the x, the derivative of the bottom is 2. E to the 0 is equal to 1, 2 is 2, so this is equal to 1/2. And that is our final answer there.